I'm from the Mississippi Museum of Natural Science in Jackson, and I've been there for about 23, 24 years, 25 or more as a volunteer, including my years as a volunteer and years as a contractor. Boy, if you include all those years, I've had over 30 years association with the museum. But my first volunteering for the museum was scuba diving, believe it or not, because the biologists were finding fossils when they were doing mussel and freshwater invertebrate surveys on creek bottoms in northeast Mississippi in the more flooded portions of streams. But they were finding Ice Age fossils in these streams. They were also finding fossils from the Cretaceous period, which is much older, but they were finding a lot of Ice Age fossils in streams. And I think I've got a picture in this slideshow of our former director finding a special one that really got him hooked on improving or augmenting our paleontology program at the museum in the late 1990s. And so that's when they started recruiting me to come back to Mississippi to work for the museum. And as you can see, they were successful. I was living in North Carolina and had some other plans in mind, but I was convinced to come back because Mississippi is so rich geologically and paleontologically. And I'm always glad that I did come back. I kind of wanted to see more of the easy geology in the Rocky Mountains and learn that geology. But I'm so glad to come back to Mississippi because it is so rich and steeped in history, and so much of it remains unexplored. Some of you brought fossils in for me to identify today, and for our group of volunteers to identify. Every now and then I see something that I've never seen before. Isn't that right, Roger? That I've never encountered before. And you better believe if we don't have it in Jackson, I'm going to recruit it for a donation. But that aside, there are things that they do crop up every now and that we're just not familiar with. And it happens pretty regularly. And there will be one of you today. If 6 of you brought something in for me to look at, somebody out of that 6 is going to have something I've never seen before. So the story hasn't been told. We're still telling the story. The story I'm telling you today is about Ice Age fossils. And Roger was kind enough to do an Ice Age, Roger Rakestraw over here to my left, was kind enough to make that his focus, very appropriately make that his focus over here. He's included a lot of the Native American aspects over there. In a way, and I'll mention this in the slideshow, we are still in the middle of an Ice Age, okay? Most climatologists agree that we are still cycling in and out of ice ages. So technically, even though we consider these prehistoric artifacts over there and relatively recent, they're still part of an interglacial period between ice ages. So it's still quite appropriate. But I'm going to review creatures, some of which you may have never heard of in my slideshow today, and which is entitled, as advertised, what? Oh gosh, what happened? I didn't mean to go to that. Oh, I'm sorry. I may have deleted that slide. Yeah, I may have deleted that slide. But anyway, what was my title taken from The Wizard of Oz? I had to delete a bunch of slides because this is another version of my slideshow that I wanted to present today. What was the... Yeah, that would be one approach.
Lions, tigers, and bears, oh my.
Right, lions and tigers and bears, oh my. And so I did a version of this slideshow in Jackson a couple of weeks ago, and they asked me to come up with a title, and I hate coming up with titles for myself. And my wife said, well, you got to make it catchy. And I thought, well, people love to hear about the carnivores. The carnivore fossils are rare, but people love to hear about them. So I'm thinking to myself, well, we've got lions, we've got bears, and we've got tigers. Well, it's obvious right there. So, yeah, it had to be a quote from The Wizard of Oz. First spoken in the movie by whom?
Dorothy.
You think that's her quote?
Scarecrow.
Well, he repeats it the second time with Dorothy. But the Tin Man is the one who tells them that's what's in the Dark Forest, not the Enchanted Forest, which comes later. And of course, the story in the book is a little bit different. the creatures, there are other creatures, of course, in the book. My wife read the book, so she informed me of this. Like there's the, what was the tiger? Who's read the book? There was the, what was the timid lions? He's called the Cowardly Lion, and then the something tiger. There was a tiger in the original story, but he's not introduced in the movie. Anyway, I'm going to talk to you about real lions and tigers and bears. Not from a story, but actual lions and tigers and bears and other creatures, some of which are still living today, that populated Mississippi during the Ice Age. So our landscape would have looked much like this, a woodland, a mixture of woodland and open prairie with enormous animals, behemoths, unlike anything that's living today, like the giant ground sloths, but some familiar creatures, like extinct relatives of the bison, and of course, a relative of the modern elephant, the mammoth. Now, what's obviously wrong with that particular landscape is that there's mountains in the background. But first, the door prizes. I don't have any Ice Age door prizes to give away. I've given them all away at other presentations, but I do have some dinosaur age stuff, which is much older. I've got those on the table over there. We've got some, they're all reproductions, an impression of dinosaur skin. It comes with a little basic dinosaur guide or booklet, a replica of a giant shark tooth, Megalodon, and a cast of a footprint, a famous footprint from a small early dinosaur from New Jersey. Those are our door prizes today. That is, again, I meant to delete all these slideshows. These are not the door prizes. That's from another slideshow. I apologize, I don't have those door prizes. So for those of you who can hear me later, I loaded the wrong slideshow. It's basically the same, but you're going to be cheated out of those particular door prizes. But for the door prizes, I'll tell you at the end of the slideshow how we're going to draw for the door prizes. And I hope you're brave because it involves writing a number on your hand with my magic markers. Is that okay, parents? Can the kids that are participating write just for today a little number on their hands? Well, that's how we're going to do that. But first, let's move on into the show, and we'll talk about the door prizes later. The fossil animals in this presentation all lived during the Ice Age. There are no dinosaurs living at that time, unless you include birds as dinosaurs, and they are. Qualifiably, they are avian dinosaurs. The birds descended from theropods, a particular group of theropods. So they are considered by paleontologists, by biologists as dinosaurs. Now, the popular culture doesn't really consider them dinosaurs. That's okay. That's fine. We're okay with that. But also, if you buy a bag of dinosaur toys, there's a lot of things in that bag of dinosaur toys that are definitely not dinosaurs. So what kind of non-dinosaur animals do you get in bags? For you parents that have children that like dinosaurs, you get all sorts of things in those bags of so-called dinosaurs or prehistoric creatures. And we get these at the gift shop that we sell to kids in the gift shop. And of course, I have to go in the gift shop every now and then, especially to new employees that are working in the gift shop, and fuss at them. These are not all dinosaurs. Of course, the people that have been there a while know that I'm just kidding. But yeah, they are, so the popular culture is always going to be behind catching up on the reality regarding biology, and that's okay. Dinosaurs sell better than a lot of other prehistoric creatures, so I think that's why that is often, that key word dinosaur is applied to anything in many things that are not dinosaurs in the prehistoric past. We are going to focus on the very top of that geologic column in the very latter portion of the Cenozoic era, when mammals start dominating the earth after the great extinction of the dinosaurs. But just the last few thousands of years, few tens of thousands of years. Our oldest Ice Age fossils in the state, and the Ice Age is also known as the Pleistocene epoch, which is, you can barely read, and it's up here. Well, yeah, it shows up better on the screen than it does on my laptop. It's a Pleistocene epoch is the scientific term for the Ice Age. And as I said earlier, we are really still in the Pleistocene epoch. It's got the Holocene separated out, and we won't go into why that's the case, but most agree that we are still in the midst of an ice age. There have been 10 to 11 major periods of global warming between the ice ages, between the ice advances. So the ice moves on the continent, and then it moves down into the United States from the north, from Canada. The same is true on the opposite side of the globe in Asia, Eurasia, and then it retreats. And there's been these cycles of less than a dozen advances, growths and advances of ice southward in the northern hemisphere, and vice versa in the southern hemisphere. And we are in the middle of an interglacial period, a warming phase. Now, during the last interglacial period, the sea levels were a little bit higher. So if you wanted to go to the coast from New Albany, you could knock 15 minutes off your drive, or maybe 20 minutes off your drive, depending upon where you were going on the coast. But during the full ice age, when ice had really grown on the continent, to where it stretched as far south as Kentucky and St. Louis, and we'll see a map in a few seconds, you would have to have a really long drive. So you would have to add up to an hour and a half drive to get to the nearest coastline, because the coastline would be near the edge, just short of the edge of the continental shelf in places. So way off the Chandeleur Islands between Mississippi and Louisiana. So it'd be way out there, a further drive. Then you probably think, well, the mountains are closer. So maybe we'll go to the mountains this year, if you're a Paleonian and you wanted to go on vacation. All fossils from Mississippi, unless otherwise stated, in this slideshow. Fossil images include commercially available casts that I often have to use because our fossil record isn't perfect in Mississippi for the Ice Age, but we do have a great diversity, but we don't have many whole skeletons. So I use a lot of stuff from Florida. We have quite a few things from Florida's Ice Age in the Natural Science Museum collection. I took all of the fossils, all of the fossil photos, and the locality photos, unless otherwise stated. The survey may have taken some of these photos. And I'll often use in my slideshow modern animal remains for comparison. In general, if you see a white bone in the picture, if you're not reading and you're just looking at the pictures, usually the picture states whether or not it's modern or not. But just put it in the back of your head that all the light-colored bones are going to be modern, and we're comparing them to the fossils, which are going to be darker. In this case, we have an American lion toe bone donated by one of our regular donors, who is a former employee of the museum, compared to cougar bone, the same bone in the hind foot, and that of the same bone in a jaguar. And we often get our modern animals, they are deceased from zoos. The jaguar was deceased from the Jackson Zoo, as was the cougar. That's how one of the many ways we gain our comparative skeletons of modern animals. Body models, skeletal reconstructions, and other examples of living and fossil animals are borrowed from reasonably reputable websites. I try to use the reputable ones. Occasionally I will name the collector and donor of the specimen when I know they are comfortable with public acknowledgement. Most people are, but we do have a few donors that prefer not to be publicized, and that's okay too. I will show you several things from the collection of Eddie Templeton. And I know you've probably heard of that name before. He goes to a lot of the shows. At least Roger. Sometimes I'll speak to Roger, sometimes I'll speak to these guys over here so that they can make a connection about other knowledge. Was Mississippi covered in ice during the Ice Age? Well, what do you guys think? I gave it away when I was briefly skimming over how far the ice got. What states did I say the ice reached to?
Kentucky.
Kentucky and Missouri, right. So that's as far south as the ice got, was northern Kentucky and northern Missouri. In this slide, I'm not sure whether this particular stage of the Laurentide ice sheet actually reaches that far south. But in this stage called the Illinoisan stage, which is about 50,000 years ago, the ice actually got that far south, so like 46 to 50 something thousand years ago. The ice got as far south as northern Kentucky and northern Missouri. Here's a geologic map of Mississippi showing you, using a variety of colors, the patterns that say something about the relative ages of all the major geologic units in the state. So each color represents a major geologic unit. So that if you were to look at this column, which we call the key over here, the key to all these units, you'll notice this dark blue right here. In fact, it's hard to notice, but that dark blue occurs right up here in the northeastern corner of the state. And as you go up the column in the Younging direction, this is gradually getting younger and younger and younger sediments. You'll see the pattern here is that as you go upwards, this is the direction that we see on the map. We see the Younging direction corresponds to going westward on the map, or southwestward, or in a southerly direction. Does my cursor show up on the? It doesn't, okay, well, that's good. So that the youngest deposits shown on the map are these gray areas here, the dark gray, the light gray, and they are represented up here. And so they're the youngest deposits, and that would include this here. So the youngest deposits of any great thickness, and that's key, the youngest deposits of any great thickness, so tens of feet thick, are accumulated in the Mississippi River floodplain, which is also known as the Delta, and the coast. Okay, this is the youngest here, and this is the next to the youngest, et cetera, going all the way up here. But focusing in on the gray, those are our Ice Age deposits of any great thickness. But we know those aren't all the Ice Age deposits, because we have Ice Age deposits from Union County over here on Rogers Table and adjoining counties, Pontotoc County. We have a veneer, a very thin veneer, relative to the thicknesses represented here. A very thin veneer of Ice Age deposits all over Mississippi. But in very few places does it actually preserve fossils. And these places can be represented on what's called a physiographic map of Mississippi. And so these places are, using this map, where do you think? And I'm going to ask Roger to point some of these places out. And you can just say them. Can you guys see that from here? I want you to name one of these places, particularly these regions where you hunt over here, as producing Ice Age fossils. And we're not giving specific sites away.
Right. I call it out by towns. You're going to probably start as far up as Dumas.
Oh, no, I don't want you to give any locations away. But
Okay.
what are the regions there on the map?
That white area. Right
Yeah, it may be hard, I'm sorry, it's hard for you to see from that angle. But that white area is Pontotoc Ridge.
Yeah. That would be the ridge line pretty much traveled all the way up, even the north and the south of it.
It's an extensive ridge line, and it's rich with fossils. It actually goes all the way to Starkville, but it doesn't have the relief that it does up here. It's very hilly up here, but that ridge line goes all the way to Starkville. Now, they've got the flatwoods there in the southern part, but that's, the Pontotoc Ridge actually goes all the way to Starkville, as does the Black Prairie, also known as the Black Belt. So those two regions are rich in fossils, but also the Jackson Prairie, and I forgot to circle it, but also the Lurse Hills and the Mississippi River. So the Lurse Hills is also rich in fossils. There's different ways to pronounce this word. Some people say Loess. You'll probably pronounce it Loess. It's a German word. Some people got Lus, Lurse, it's all the same thing. It's also known as the Lurse Bluffs or the Bluff Hills. This area is rich in Ice Age fossils, as is the Mississippi River. Mississippi River cuts through a lot of Ice Age fossils, fossil-bearing deposits. But at the surface, here in the Yazoo Basin, most of those deposits are covered. Most of those Ice Age deposits, at least the ones that yield fossils, are covered. All of it's Ice Age, but there's only certain intervals, certain layers that produce fossils. It has to do with the chemistry of that layer. Okay? So not all parts of the Black Prairie produce fossils, but the Black Prairie in general is a place that has Ice Age fossils. You just have to know where to look. and to know where to look, you gotta really get to know me or Roger or Tim. And we don't give that information up easily, do we?
Dustin.
Dustin, yes, I'm sorry, Dustin, I didn't mean to leave Dustin out. Well, going back to the geologic map, southernmost Mississippi and the Delta, in fact, that's a slide that I've already covered that.
One
And let's-
question on that, when it's Ice Age in Kentucky there, where's Mississippi at that time, water?
No, so we're all land at that time.
We are.
Yeah, so these animals are living on this land. It's not like the Cretaceous period where we're under that shallow seaway. And the only terrestrial animals we get are washed out to sea, so it's a different situation.
Pushed into that area because there was only living conditions they could be in, I guess, because of the ice. Because of the ice.
Right, yes, that is correct.
It was pushed into this area.
That's correct. So so a lot of animals are displaced during the Ice Age. Whole ecosystems are displaced during the Ice Age, and they're sort of squished into a much decreased depth of latitude. So some of those ecosystems persisted that we have today, persisted during the Ice Age, and some of them just completely reorganized. Well, and I'll tell you about some of these animals that we're going to discuss are living in the area today. Some of them are not living in the area today, and many of them are just extinct. So it's a whole major, the global warming that happened 11,000 years ago, or actually starting around 13,000, 14,000 years ago, just remixed all the ecosystems. And it happens with each ice age. There's just this reorganization each time. So one common question is, was the temperature cold year-round? The larger extinct animals are always portrayed as being hairy or even shaggy. And that is a misrepresentation. Certainly at more northern latitudes, certainly around the periglacial regions, the area around the ice, those animals obviously need an extra protection from the cold. But this far south in Mississippi, particularly in southern Mississippi, in the southern part of the old coastal plain, a lot of these large behemoths had no hair or very little hair, period. And we'll speak to that here in just a few minutes. They were just as, our mastodon may have been just as hairless as the Indian elephant we see here in this picture. The same with the mammoth. They almost certainly had some hair. Some hair has been found associated with animals preserved, particularly along the edge of the ice in Indiana and Illinois, but not the amount that you think would be on these animals, at least not as they're portrayed in the popular literature. The environment at that time was actually where we are in Mississippi, more equable with lesser seasonal extremes, namely cooler summers. And that's really all you need to get to grow ice on the continent, is to reduce those summer highs. And if there was a way we could artificially reduce summer highs, we could probably create another ice age. Who knows, we may have that ability somewhere down the road. But that's all you really need. The main thing, the main ingredient in having another ice age is to cool down those summer highs so that you can have your precipitation preserved on top. You can develop a snowpack that turns into ice at northern latitudes. The total composition of each physiographic region, or physiographic district or region, suggests a mosaic of forests with insular prairies. The latter partly created and maintained by the megafaunal herbivores. This is a map of what some of you may know if you know Monroe County, the Monroe Prairies, as settlers first encountered them. Now for thousands of years, these forests in Monroe County and adjoining Chickasaw County and Clay County, these forests and their prairie mosaic in the middle of them were maintained by the Native Americans. Don't think that the Native Americans did not have an influence on the landscape. They certainly did, and they managed the landscape. They were almost certainly better conservationists, better conservators, better trustees of the landscape than we are today, without a doubt. They managed the landscape very well. In fact, further north, you've heard of the Chickasaw Oldfields.
Yeah.
Those were probably originally prairies at one time. But as soon as the Native Americans learned slash and burn farming, they were able to maintain the landscape for their needs. But they probably lived in a greater, and that's what the evidence suggests, a greater ecological balance than we do today. But yeah, so this map is based upon what the original surveyors saw in the 1830s, late 1820s and 1830s. That's the landscape they saw. And that was compiled by a professor at Mississippi State University. Before he came to the university, he was I think he was a student there, and he went off to a college in Massachusetts and produced a PhD specifically on everything that was known about the Black Belt or the Black Prairie at the time. And he took all these old surveyor notes and their sketches, what do they call them? They plotted the existence of these bearing trees that they used in their surface mapping, and that's how they were able to create this map. This is the first map of the Black Prairie District ever created. Today, North America lacks the large creatures that maintain the more open landscapes. So what you see here in this configuration is what was being managed by the Native Americans. It was probably almost certainly much more open when the Ice Age megafauna inhabited the area. You see a variety of trees today, like the honey locust I've illustrated here, and the Osage orange, and others, that just seem so incongruous with respect to our current ecosystems. Why does a honey locust have to have such wicked thorns coming out of the tree? What is it defending itself from, like what?
Herbivores.
I mean, what was the biggest herbivore that would have possibly grazed on a tree prior to settlement of this area? What was the biggest herbivore? Well, we definitely had deer, and there were probably bison, okay, migrating in and out of the Black Prairie and other open woodlands. But it wasn't protecting itself from the bison, the onslaught of the bison. Bison is principally a grazer. Horses were in North America during the Ice Age, but they've been extinct for 11,000 years. And what about the Osage orange? Why are the fruit shaped like that? That's not appetizing to anything. You know, what feeds on a fruit? So, an interesting thing about the people who have tried to horticulture these plants. The honey locust, to be successfully propagated, to be truly successfully propagated, its seeds have to have a near zero or sustained sub-zero temperature for a certain amount of time for them to be propagated. I'm sorry, that is the Osage orange. I apologize. The Osage orange is that way. That's one of the requirements of the Osage orange. For it to propagate successfully, that is to produce a lot of trees. For the honey locust, successful propagation, maximal propagation, is exposure to acid for 2 days. Sulfuric acid, I think, is what it's exposed to. For a minimum of 2 days for really good propagation. So these are plants that have to have certain types of propagatory methods to be truly successful in a landscape. And this might have been provided by animals during the Ice Age. The Osage orange fruit, I can easily see it being eaten by a mastodon or a giant ground sloth. Now, some of you are probably aware that there was speculation that the Osage orange is not native to this area, and that who's heard that story? That it was reintroduced by people moving back east. Yeah, and that appears to be false. And now that information is not available to everybody. It's kind of obscure, and much of it hasn't been published. But there is archaeological data and paleontological data that the Osage orange has been in Mississippi for a very long time. It was not reintroduced, as you might have heard, for these as a hedge tree, or, and, you know, that may have been a use of it, but it wasn't reintroduced because of that. It has always been here.
Isn't the nickname horse apple?
Yeah, the horse apples, yeah. Now, whether the horses ate them during the Ice Age, I have no idea. So, now we're going to talk about the animals. Now, I have 100 species. That seems intimidating. But I'm not going to focus on all those species. We're going to breeze through a bunch of them. And, you know, if we see a lot of people leaving by the time I get to the shrews, we might break it up, and I might do the rest towards the end of the show. But I'll try to breeze through as through the meek creatures as much as possible. You see the cool guys, the big fellas, as much as possible. But which ones do you think we should get to first? What if you're creating a bestiary or a collection of animals that have some relationship with one another? A lot of the times the word term bestiary is used with relation to talking about animals in mythology. But it also be used to talking about a group of animals really in anywhere and in any circumstance. And here we're talking, our circumstance is the Ice Age in Mississippi. So what critters would be appropriate to begin with, do you think?
Beaver?
Short-faced bear.
Pterodactyl.
Okay, now remember I said I might breeze through the shrews, the lowly animals. I said they're not lowly, they're great. I mean, they have a really high metabolic rate. Not that of birds, but nevertheless they do because of their small size. So they're pretty cool animals. They're very busy animals. So who should we start with now that I've given you that hint?
Must be the shrew.
Well, we're gonna start with even smaller animals. So something that shrews eat, snails.
No.
So we don't have a great record for invertebrate animals in our Pleistocene fossil record. We have a few, and one of them are these snails that are found sometimes in great abundance in the Lurs Hills. Remember these are the hills that line the eastern margin of the Mississippi River floodplain, or the Delta, also known as the Yazoo Basin. And they are just prolific in these deposits that are largely wind-blown deposits. And that's the Lurs. That wind-blown sediment is called Lurs. It seems to be a mixture of wind-blown and water-deposited or alluvial. But much of it is a great portion of it is largely wind-blown. And these terrestrial snails, Alagona, love this material. They must have, because in what sort of nutritious food they found on the surface of this Lurs. The Lurs is a very, very fine sand. In fact, it's not even sand. It's lighter, it's smaller than sand. It's very fine grained, we call it silt. And it's got a lot of this mineral in it called calcium carbonate. And it's possible that there were bryophytes growing, like mosses and things like that, growing on the Lurs, and possibly that's what they fed on. I don't know. I'm not a specialist in snails, but they are very prolific in the Lurs Hills. We occasionally see them preserved in the Blackberry and along the Pontotoc Ridge.
Yeah.
We also find freshwater mussels in our Ice Age deposits. This little sample of mussels were preserved in this irregularly looking block and only preserved as molds. You have a modern shell for comparison in the upper right of that photo on the far left for comparison, but what you see embedded there, actually if we could flip that object over, you'd see 5 different molds of this shell. And it seems to be this three-ridge mussel, which is still living today. We see that it was very prolific, at least in this kind of deposit. And now we're going to talk about the fishes. A rather low abundance and diversity of fishes and numerous other small vertebrates are preserved in our Pleistocene alluvium, our Ice Age alluvium. This is due in large part to their fragility of small animal skeletons in general, particularly birds, and it's really regardless of the size of the bird. I'll tell you about one bird that we do find quite a bit of, but most of the birds their bones are very delicate and quite hollow, as all bird bones are. But they just do not survive being deposited in streams or being worked into stream deposits. Streams are generally high energy, or at least part of the time. The sediments are coarse, and there's long exposure times, and these bones are tumbling around in streams, and it just works against the preservation of the smaller critters because their bones are basically being ground to bits. Upland fossil localities, particularly in the Black Prairie, contain low-flow stream deposits, which exclude many of the larger fishes and larger aquatic and semi-aquatic animals. The deposits of sluggish and perennial streams contain more fragile and smaller bones. So we do see a difference, and if you want to hear the details, just read my thesis from years ago. But we do see a difference in the composition of Ice Age fossils from modern upland elevations to modern lowland elevations. And if you thought that there was a difference and you wondered why, it is a real difference. It's not just an imagined difference. Certain bones preserve better than others. And in the case of garfish scales really preserve well. They fossilize really well, and they're very durable. They're made of this material called ganoin that's very similar to enamel and other dental tissues. In fact, they're kind of glossy. That coating on the surface of the scale is kind of glossy, and it's very hard, like enamel is. We also see bowfin, which is a distant relative of gar. We see a variety of other fishes, and they're going to be mostly big fishes, because the smaller fishes, their bones are getting, as I said, ground up due to the circumstances of the preservation. Here we have a jawbone of a bass that was found in a creek bed in Mayhew, Mississippi. We also find a lot of drum fossils. Drum are made of, their bones are just so sturdy. They're not armored, but when you look at their skeleton compared to another fish skeleton, they look armored. They look really sturdy. And their scales are just as delicate as other fish scales, but they just look, when you look at the skeleton compared to other skeletons, they are a sturdy skeleton. So many of the fish bones we find are drum, and their teeth are very long lasting. They're very durable, they're very hard, so we see a lot of their teeth. We also see catfish spines, and that's a lucky thing, because if we're finding just individual bones, the catfish spine, which we see more of than any of the other catfish bones, primarily because it's so sturdy. But that catfish spine, which it uses on the, it's near its opercular chamber, its gill chamber, and it sticks those out, and that's part of its protection. They're very species diagnostic. We can identify at least genus and sometimes species based upon the shape and the ornamentation of the spines. So we know this is from a bullhead catfish, that spine there, and we know this tiny little fella, millimeters for scale, is from a mad tom. It's a relatively large mad tom, one of the largest in the state. I think Chris has caught this mad tom, actually the tadpole mad tom. But yeah, so we're lucky that if we're going to find just one bone, if it's going to be a common bone, it should be species diagnostic to maximize identification. And in the catfish spines, that's certainly the case. We find amphibian remains, most commonly frog and toad bones, like these bullfrog hip bones, and bones of other frogs. A lot of the frog bones we can't identify the species. We know a couple of, same as with the toad, we know there's a couple of species, but Roger, I hate to stretch.
Good.
If the only person that showed up for this show was Roger, he'd stay all day. But he really needs to see a lot of this. We find cottonmouth remains. This is one of our best vertebrae of a cottonmouth. They're pretty sturdy, and it's a big snake, so those bones tend to survive a little bit better than others. But we do find some unidentified water snakes and king snakes. Now in Alabama, in the Black Prairie of Alabama specifically, they have found, paleontologists over there have found indigo snakes. This is me holding one of our indigo snakes that we use for an educational animal, for educational demonstrations at the museum. This is the northernmost record, Chris, as you well know, that would be the northernmost record of the indigo snake, because it's generally limited to the southernmost third of Alabama and Mississippi. But apparently they lived in the Black Belt, or at least parts of the Black Belt. Now the fossil-bearing alluvium that this snake was found in, this is pretty sandy. So it's not too surprising that this was found, because they live in areas that are somewhat sandy today, which is typical of the southern third of Mississippi. We have a couple of different soft shells show up in our fossil record, the spiny soft shell and the smooth soft shell. And generally speaking, the smooth soft shell today is an inhabitant of larger streams and flowing streams. Spiny soft shells are almost more regularly encountered in smaller streams. You see this guy way up prairie streams. And during flooding events, these females, when they're going up these small prairie streams to hatch, they get trapped in pools as the waters recede. And I'm sure a lot of those that you get out in the wilderness, you outdoorsmen, have probably seen these big females, the size of a tire, trapped in these pools. We hope the next rain carries them out so they can continue the cycle of life for soft shells, but
Step on and they take out.
yeah, that's right. Yeah, sometimes they bury themselves in the mud and you don't see them. You don't see them. So when we find their fossils, for example, we find most of the soft shell that we find in the Mississippi River deposits are smooth soft shell. And the ones we find in the Pontotoc Ridge and Black Prairie areas are spiny soft shell. And that makes sense because the landscape hasn't changed much today with respect to things like the distributions of streams and rivers. So it makes sense that the smooth soft shell, which prefers larger streams today, would be the dominant soft shell we see in Mississippi River deposits. Here's an example of each. There's a modern spiny soft shell for comparison. Now these are broken specimens, so do not let the entirety of their shape suggest anything about absolute identity. I have to look at these things up close, and there's a lot of variability in the shell. But just because you see the smooth soft shell shaped like that doesn't necessarily suggest something. There are details that you have to see when you look at them up close, because that smooth soft shell piece is just a fragment. And that's mostly what we're dealing with, is very fragmentary remains. And we also have snapping turtle remains in our fossil record in the state. There's our alligator snapping turtle on the right, if you're unfamiliar with how much bigger and more menacing they look. But they're certainly a lot more tamer than a common snapping turtle. They don't have quite the reputation. They look like they'd be worse than a snapping turtle if you were to corner one, or one were to corner you, as the case may be. But they are not near as menacing and vicious as a common snapping turtle. Now here's some examples of bones of snapping turtles. The bone on the far left-hand corner, or far left-hand side of the screen, is actually part of the ear bone in the common snapping turtle, a fossil example of a common snapping turtle, compared to a modern skull that's just above it. And here's one of the arm bones, the upper arm bone, or upper foreleg bone, obviously in a turtle. And here's one of our biologists, found a big surprise while he was out surveying for mussels, and he found it on a stream in right where it flows into the Pearl River, and it's a piece of a fossil alligator snapping turtle shell, and it's from along the margin of the shell. And a collector in Tupelo donated this specimen on the far left, and it's compared to the same bone from the center, along the center of the back of the shell, the carapace of the shell. And I think it's neural number 3, bone number 3 along the back of the shell. So not much change from the Ice Age to the present. So that's how we're able to get a lot of these two species. And some of the features that we use on shells, these musk and mud turtles as an example, they're easy to tell from one another. The scales that you see on the bottoms of these shells, they leave impressions. So the scales themselves don't preserve, but they leave impressions in the shell, the margins of the scale. Here's the margin of this scale around the rim and the margin of this scale. And sometimes these grooves will leave impressions in the bone, and those become important in the diagnostic potential of these bones. And here's just some examples of the differences between musk and mud turtles and how we're distinguishing them from one another and from other turtles. We don't find mud turtles in the fossil record in Mississippi. Now, finding something is interesting. And if you find an animal, if you identify a species from a fossil deposit or from a locality, you can obviously say that animal lived there. In most cases, that is the case, okay? What's problematic, though, is with respect to the Mississippi River, if you find a bone in the Mississippi River, you don't necessarily know how far that thing traveled. okay? That's the default understanding. If you find it in the river, that thing could have tumbled a long way. Well, it could have tumbled a long way before it was fossilized. So a green bone or a fresh bone can travel a long way, much longer than after it fossilizes. The fossilization process, unfortunately, decreases the survival of the bone. Sure, it gets the bone from 66 million years ago or whatever to when you find it. But as soon as those bones are taken out of their burial context, they start falling apart. Roger, he's got an example over there. He's going to show you later if you haven't seen it already. Fossils start to disintegrate. It may take years, it may take days, it may take decades. So we have a variety of things that we use to preserve fossils with. So the bones that are found in the Mississippi River, they may have traveled a long way before they were fossilized to that point. But after they fossilize, they don't travel far at all. They just begin to disintegrate. And there are ways that we can tell how far they traveled before they became fossils. But with respect to the mud turtles, everywhere we see them in Mississippi, everywhere we don't see them in Mississippi, that says something about these environments where these fossils are preserved. I won't belabor that. I'll only say that the absence of something is often, when you think it should be there, and it should be there, tells you something about the environment. It betrays something about the area. Because we know mud turtles are found in other cases in other places in adjoining regions. We know they're found in Florida. They're very abundant in Florida. They've been found in eastern Texas, in the Black Prairie of eastern Texas. But anyway, yeah, so something that's absent is just as important as something that is present. Here's an examples of the common musk and mud turtles. And we actually find quite a few of both, particularly in the Pontotoc Ridge and the Black Belt, or Black Prairie in northeastern Mississippi. Now, musk turtles the common musk turtle still lives in the area, but the razorback musk turtle, no longer lives in northern Mississippi or central Mississippi. We find a variety of pond turtles. The pond turtles collectively include the sliders, the cooters, and the paints. And here's obviously some modern examples of these guys.
You say they don't live here no more, they come extinct, or they move further away?
Oh, so the razorback musk turtle is still living today. It's living in southern third of Mississippi. Right, so it became extirpated from northern Mississippi. We're not sure how far north that the razorback musk turtle lived, but at least the Black Prairie. And possibly all the way up to the Tennessee line. I'm not sure about that yet. I'm still working on that material, keying out that material. Now with respect to the pond turtles, here's an example of turtle remains from the East New Orleans back levee. These are fragmentary turtle remains from the East New Orleans back levee. What do you think of when you think of the East New Orleans back levee for everybody that is for everybody that is more than 12 years old? What do you think of when you think of the East New Orleans back levee? And I'm giving it away for people that are more than 11 or 12 years old. Dustin, you know you want to say it.
Alligators? I don't know.
2005.
2005.
Oh, man, yeah, never mind.
August, yeah.
Yes.
As soon as he said 2005. August of 2005, was it August 29th when it landed? So, the reason I have, in a roundabout way, that I have this collection of turtle shells from the East New Orleans back levee is connected to a practice that is no longer used in repairing of the levees. Because this practice that lasted up until maybe the mid-1980s actually compromised the integrity of the levees. And it may be partly responsible for the way the levees were maintained early in their lives, as far back as the 1930s. So it was the way they used these pipe dredges to get material out of the intercoastal canal and then build the levees. These days they mine sediment from further offshore. But anyway, all that aside, not to get into the engineering aspects of it and connect this to Katrina and the failure of that levee, and they are connected, it's a connected story. And if you want to hear more about it, I can talk to you about it after the slideshow. But there were two collectors that we know of, and when we were building this story behind this levee was loaded with fossils and artifacts that came from depth. It was mined using a pipe dredge. And they hit at least 3 paleontological levels and multiple archaeological levels. And these two men, one of whom became friends of the museum, wanted their stuff to go, some of their stuff, they kept a lot of it, but they wanted some of their stuff to go to an institution. And most of the fossils came to the Mississippi Museum of Natural Science, including these turtle shell pieces. And these turtle shell pieces were really broken up because all this material is being sucked through a pipe dredge, and it gets almost destroyed in many cases. But some of those shells survive, and we were actually able to identify the different species of turtle, at least the genus, using just fragmentary remains like that. But over 12.5 different species of animal were found just in the Ice Age layers at the East New Orleans back levee. The box turtles are interesting in their distribution today. Some people break them up into different species. Some people suggest they're different subspecies as regards their ranges. Whatever they are mixing where their ranges overlap. And we see this happening with the Carolina box turtle and the three-toed box turtle. And we see it happening throughout much of northern and central Mississippi. These 3 turtles that I'm pointing to on the map are perhaps, at least their ancestors, are perhaps players in identifying what we find with respect to the very fragmentary turtle remains in our Ice Age deposits. So for northeastern Mississippi, we're finding something that looks like a cross between the eastern box turtle and the Gulf Coast box turtle. And our Ice Age deposits in southwest Mississippi seem to be yielding something that's akin to the three-toed box turtle. The Gulf Coast box turtle is the largest of the modern box turtles. And so we had box turtles in northern Mississippi that were 2.5 times the size of what you see in the Black Belt or the Pontotoc Ridge today. Here's some examples of that. On the dark one here on the far right is from around Mayhew, Mississippi. It's compared to a modern specimen of average size. Both of these are of average size from the samples from which they came. So that's a three-toed box turtle, which we don't think was in northeast Mississippi at all. There's no evidence of ancestor there, at least as far as we've been able to ascertain. And that's compared to a fossil specimen. So just based upon that individual element alone from the left side of the shell, from the front left portion of the shell, just using individual pieces in the shell, we were able to identify that as some type of box turtle, probably more closely related to the Carolina and the Gulf Coast box turtle. We also see turtles that live in much northern climates today. The wood turtle, for example, that inhabits the modern Great Lakes in New England, its ecosystem did not exist during the Ice Age because of the ice inhabited this area. So its range was pushed much further south. And here's some excellent examples of individual elements from the wood turtle shell from the Tupelo area and from the Mayhew area. In fact, I think that all of these are from the Mayhew area, but I have just as many from the Tupelo area. Blanding's turtle also is an important player in our Ice Age fossil collection. It's also a cool to cold temperate turtle living around the Great Lakes and New England today, and it also shows up in our Ice Age fossil record. For the Mayhew locality, we actually have a significant proportion of our turtle assemblage, of all the turtles. Upwards of a sixth of all the turtles are composed of the wood turtle and the Blandings turtle, which are more cool temperate as opposed to warm temperate turtles today. We have map turtles. The map turtle we find in the Black Belt is largely the Alabama map turtle, which inhabits that area today. And for the Mississippi River Basin, we see mostly the false map turtle, which, again, inhabits that area today. Gopher tortoise is extremely rare. In fact, the gopher tortoise fossils, or the presence of gopher tortoise in northeastern Mississippi is based upon one single specimen found by my mentor, for whom the fossil park in Columbus is being named. And it was just one element, but it does pin down at least the southern portion of the Black Belt, which would, like the indigo snake, would be the northernmost occurrence of this species because it's mostly a more southern animal. But we had plenty of giant tortoise. We regularly encountered giant tortoise remains in Mississippi, both in the Mississippi River deposits, the Lurs Hills, and in the Black Prairie. An example of a silhouette of gopher tortoise and the giant tortoise for relative size comparison. In reptiles, they have this entire bone attached to their shoulder blade. The shoulder blade and this bone here, the coracoid, makes up the shoulder assembly of reptiles. For us, it's just the one bone, and our coracoid is actually attached to it's part of our shoulder blade, our scapula. But here's a gopher tortoise, a modern gopher tortoise comparison compared to the giant tortoise coracoid. Just an incredible difference. Now, I know most people would like to see an entire skeleton of a giant tortoise compared to a reassembled skeleton of a modern gopher tortoise. But again, we just have fragmentary remains, and that's typically the case for most fossil records. Complete or even just partially complete specimens are
Can I ask a question?
very
George?
rare. Yes.
Remember that big turtle we went and took pictures of years ago out of the creek?
Oh, the one that was here on display
Yeah.
for a number of years?
Was
Yes,
it
that
a-
was Cretaceous.
Okay.
That was Cretaceous. That was a marine turtle, yeah. It was a big fella. It still wasn't as big as this guy. At least with respect to body mass. Yeah, maybe it was the same diameter, approaching that diameter. This is my pocket knife. It's this pocket knife. It's a Swiss Army pocket knife. Obviously, I spent some time sojourning with the Swiss Army. That's how I got this. This is how we all get it. That's for scale. That's for scale next to just one of the plates along the back of a giant tortoise shell. This is a massive, massive animal. These bones are very curious little bones, not many people know about, but they're around the rump region and hind legs of all tortoises. I'm pretty sure all tortoises that are currently living today all around the world. They're definitely around tortoises of the Western Hemisphere and their ancestors and their distant fossil relatives. So on the bottom in my hand, the lower part of my hand, I am holding a portion of the rump armor of a modern gopher tortoise. So again, gopher tortoise is very small, and so his entire rump, or her entire rump, on either side of the tail, as you see in that diagram. So that's most of the rump armor of a gopher tortoise, and there's one of the individual elements from the rump armor. And as you probably already guessed, that's just one of the individual elements from a giant tortoise, one of its ossicles, as they're called. Have I left any reptiles out in covering the reptiles? A logical reptile existing in Mississippi today that, gosh, it should be here during the Ice Age. It should be recorded in our Ice Age deposits. What reptile have I left out?
Like,
Alligator.
I've left out the alligator. The alligator should show up. You'd think it would. And it does show up in the Ice Age deposits of Florida, but it is apparently not found anywhere in our Ice Age deposits, neither in western Mississippi or in eastern Mississippi. It seems to have not liked the cooler waters and generally cooler climate further north. Yeah, to this date, no alligator remains from our Ice Age fossil record. Now, remember that we don't have Ice Age fossils preserved in South Mississippi. We have Ice Age deposits in South Mississippi, but they do not bear fossils because they're too acidic. Among the mammals, let's start with the possum. So we have possum bones preserved in our Ice Age fossil record. That goes without saying. They're living here today. They've long established here. Swamp rabbit and cottontail, we find those, as do the eastern mole and the southern tailed shrew. The bone that I'm using for display here is an Ice Age mole ulna bone. That's this bone in your forearm. This is their bone in their foreleg, compared to a modern ulna bone. And a variety of rats and mice. Perhaps the two most important of the rats and mice found in our fossil deposits are the meadow vole and the southern bog lemming. And they are what we call climate indicators. They're only found in the southern Appalachians today. And like those cool temperate turtles, these are generally cool temperate mammals. And they're just not found in the lower elevations in the south at all today. The only place they're found in the south, as I said, is in the southern Appalachians. So they don't like our warm weather. So they retreated to the southern Appalachians, which again is their southernmost occurrence today. And we find a variety of squirrel-like animals. And of course, the beavers, particularly the giant beaver. Giant beaver, again, several times larger than the modern beaver, the size of a black bear, essentially. Horses. We know that horses are well established and kind of successful where they are allowed to go wild. And of course, they're very successful in pastures when horses can be managed, and they don't have to be managed. We have the wild Mustangs out west. One of my former volunteers, not with me anymore, she's still alive, but she doesn't, her husband are moving away from the area, but she was part of the Mustang placement program once upon a time. There was a division based out of Hattiesburg, Mississippi, a Hattiesburg office. Well, it was north of Hattiesburg, but it was in southeast Mississippi. The fossil horses of Mississippi were probably much like the modern Przewalski's horse. They were very likely fawn-colored. It seems to be a neutral color. It seems like when horses are allowed to go wild, and it's true of dogs too, they return to this native state. And that native state includes behavior, and it can often include appearance. For example, with dogs, domestic dogs, they return to this state called, one of them is the Carolina Cur. And apparently, regardless of where you are in the world, when dogs are allowed to breed in a feral state outside of management by humans, they return to this dingo-like dog, at least with respect to its body form. They don't, after several generations, they don't look like a pug anymore, except for the fawn color. Most pugs are fawn color. I guess there's black ones too. But yeah, they return to this native morphology that's that their genes are being expressed naturally instead of unnaturally, artificially. This is one of our most complete specimens. Again, we don't have many complete specimens or even partially complete specimens of fossils. And this is one of them. We have a partial leg of a horse that was found in Yazoo County, not far from Lexington, Mississippi, where this gentleman and his wife live. And they found this leg embedded in a creek bank and were able to dig it out, and they presented it to the museum because they knew it was very special. And the same with this, in the same area, same creek, a landowner and his scouts, his son was scouting at the time, and he was at least a standby scoutmaster. Because of his job, he couldn't do it all the time, but he took the kids out on a field trip to the same creek bed, and they found a whole horse jaw. And he called me right away. This guy's also a distant cousin. And he called me right away. And of course, he didn't do this, I think, because we were distant cousins, but he and the scouts were big fans of the museum. And he said, you need to get down here and help us get this out. There's no way, it's too fragile, we can't get it out. But you need to come tomorrow because there is a storm coming. And we had actually monitored the storm for a couple of hours. Then we decided that I needed to get there probably around 7:30 at the latest, because it was, this creek really swells with water. And we knew it was gonna be a deluge, and the creek was already sort of high. Long story short, you can tell by the tone of my voice. I got out there about 15 minutes too late. The water had already covered it. And it was under 4 feet of water by the time I left. And it totally removed the horse jaw. One of the collectors that's in my inner circle, he was down there a couple of weeks later and found a couple of teeth that we think might go to that jaw. It's hard to say. But we almost had a complete Ice Age horse, or at least a half jaw. The front teeth were missing, but I so wanted to get out there, but it wasn't in the cards. A relative of the horse is the tapir.
I have a question about
Yes.
the horse. Once upon a time, your buddy from over at Ole Miss told us about a Pleistocene horse that had been found up the Cane Creek bottom somewhere. I don't know whether it was in Tippah County, early Tippah County, or late Union County in the 40s. Tell us that story and where that is and what you know about that.
So was it horse or mastodon?
Well, he
Horse.
said Pleistocene horse.
Yeah, Charles.
Yeah.
Yeah.
Charles Warren.
So I remember the story, horse is mentioned, but I think it's in a Geological Survey bulletin. And mastodon is mentioned specifically. We have what remains of that mastodon. But it was a situation, the horse, to me, the big story of that story was the mastodon. And I'm forgetting offhand that there was a horse involved in it, but it now sounds sort of familiar. But most of the discussion in the bulletin, I think it was in Union County or Tippah County Mineral Resources or
Union
something.
County.
Somewhere up there close to the
Yeah,
line.
one of those bulletins that seemed to be the focus. But this is a case where I think the landowner wanted to keep part of it. And basically everything that he didn't want came to the survey. And so maybe the horse material remained with him.
Okay.
But we have what was left of what the Ole Miss brought back. And we have that curated at the museum. And similar situations happen where the landowner wants to keep part of it, and of course the story ends there, because there's no telling where the fossils go. But all we have is what those geologists brought back. I think Earl Vestal was the geologist at the time. And so he deposited that material there. But yeah, it happens. There was a similar situation with a mastodon in the South Delta. Fortunately, most of that, the landowners eventually donated most of that to the Mississippi Museum of the Delta. And that material is on display there. They were not interested in keeping any of the remains when they found out how fragile and, because it was going to be a job to preserve it. But yeah, that did happen, and it's recorded in our State Geological Survey bulletin. Either the Tippah County Mineral Resources, and I think it was the Tippah County Mineral Resources bulletin. But yeah, tapir are found. Tapir are not uncommon. They show up with some regularity. Where you're going to find the horse bones, you typically find tapir bones. Tapirs seem to be most abundant where you do find more aquatic animals. Modern tapir do like to spend a large part of their day near water. They're very amphibious. They're as much as home in the water as they are grazing alongside cattle in Argentina today, and in Central America as well. Capybaras are like that too. We'll get to the capybara. But yeah, it's two amphibious animals. In fact, the capybara is even more water-loving. It has been hypothesized that some of our fruiting trees for which we don't have any modern animal feeding on them here in the southeast, were probably regularly fed on by tapir. There are fruiting trees in the modern tapir's range in Central America in particular, where most studies have taken place with regards to what they feed on, the fruits they feed on, where those fruits don't germinate unless they pass through a tapir's guts, or those seeds do not germinate unless they pass through a tapir's gut. Here's an example of a jaw found by one of our former directors of a tapir. This is a jaw where the teeth that erupted, the baby teeth, this is a jaw from a juvenile. It was a stage of replacement where the baby teeth had actually already fallen out of this jaw, probably due to it being tumbling around the river where it was found. This is from the Mississippi River. But you can see the erupting permanent teeth there in the middle of the jaw, right here. Teeth erupting, inevitably replacing the baby teeth. People often confuse modern pigs and even modern tapirs with this animal, the long-nosed peccary. I'm sorry, the peccary. Peccaries are still living in the Americas today. There's the javelina of Texas, but there are two other species living in South and Central America. It is a distant relative of the pig, and its ecology is rather like that of a cross between a pig and a deer, if you were to suggest what it fed on and the niche it occupied. And its teeth are similar to tapir, but it filled this niche, as we call it, this sort of job in the ecosystem that was somewhere between all those three. Long-nosed peccary and the flat-headed peccary are the two types of peccary that we found in Mississippi. Now, I mentioned that regard to the turtles, we see certain species are more common at higher elevations and certain species are more common at low elevations. That is certainly true of these peccaries. Elsewhere, outside of Mississippi, where peccary remains have been more extensively studied and published on, the flat-headed peccary has always been figured as a more open environment animal, prairie-type animal, and the long-nosed peccary more of a forest-dwelling peccary. And long-nosed peccary were very stilt-legged and had a long snout like a deer, so it's thought that their niche that they filled was similar to the white-tailed deer. And flat-headed peccary were stouter, more like a boar. But the flat-headed peccary we have only found at higher elevations. So for example, in the Golden Triangle, one of the higher elevations where we find it is in and around Stark. We have lava remains preserved in Mississippi from both the Black Prairie and the Mississippi River, but they're very rare. Since our deposits, our Ice Age deposits, were largely deposited by streams, we're thinking that like modern llamas and camels, that they weren't spending a lot of time around streams, that most of their time was spent outside of what we call riparian environments. Those environments immediately associated with streams, which have their own dynamic. So this is not an animal we might expect to be found regularly along streams, but obviously they need water, so they would spend a certain amount of time around streams, but they didn't linger around streams. They may have been more common than we perceive in the fossil record. In Florida, they are very abundant. Their remains are perhaps just as abundant as deer remains in Florida. But they have environments or landscapes that preserve fossils that our stream deposits do not. And of course, we had a couple of different species of bison, including the largest of all the bison that ever lived, the giant bison, Bison latifrons. This is a shot of one of the most famous skulls of bison latifrons ever found and excavated. This shot is from 1954 at an area called American Falls. It was found near a dam site, I guess when they were doing dam construction. And several skulls were found in the area, but this was the most complete. And this is also the most reproduced giant bison skull ever. It was available, I don't know if it was I think it was the Idaho Museum of Natural History, got permission from the federal government. I think the federal government owns the property, so they have legal possession of the remains from the American Falls. But the state of Idaho is the official custodian of those fossils. And this one, somehow there was an agreement that it should be molded and cast because it was so impressive. And I think it was the Idaho Museum of Natural History or the Illinois Museum of Natural History. Someone contracted with a museum to produce a cast of this skull. And this is the skull called Mary Lou that's on display at the Museum of Natural Science. It is the cast of the skull. We don't have the original. The original is at the Idaho Museum of Natural History. We have a reproduction of this skull. We have one of the first reproductions from that skull. Our sloth skeleton on display down in Jackson is also the first or second to come out of the molds produced by the Illinois Museum of Natural Science. This skull right here is so famous, it earned a name, Mary Lou. And that name, Mary Lou, comes from its finders, Mary and Lou. So we have a variety of animals, this certain group of ungulates. In fact, these are almost all of our ungulates in this particular list. At least it's the horses, the tapir, the peccaries, antique bison. And the horses were reintroduced, but most of their evolution took place in North America. And the same is true of the llamas, which I don't mention in this list, but it's also true of the llamas. The same is true of the peccaries. Well, I do have the stout-legged llama in this list.
Is that considered what we call the camel we find?
Right. So that's all llama. In fact, we don't suspect it's anything other than the stout-legged llama found in Mississippi. The true llama seems to disappear around the Mississippi River Basin, and we've not even seen it in the Mississippi River itself. So it probably disappears. It's found no further eastward than probably the easternmost Great Plains. So what ungulates or hoofed animals are missing from this list that we haven't talked about, but have mentioned briefly? Pardon?
Cattle.
Well, that's true. Cattle would be, our cattle category is covered by bison.
The deer?
Pigs.
The deer, yeah, so we haven't mentioned the deer. Let's talk about the deer. So everyone knows we have white-tailed deer in Mississippi, and so we had white-tailed deer during the Ice Age. They did not look exactly like, at least those that we recovered from the Black Prairie, seem to have been a smaller antler deer. Their bones are about the same size, but we never find any big antlers. They all seem to stop growing at about by the 4 or 5 point stage. And they don't have a very large diameter burr, for those of you hunters that know what I'm talking about. They seem to have been small antler. I have no idea. That's an article right there. I don't know why that's the case. But all the other bones that we find of them, they're generally about the same size as the modern white-tailed deer. Now, we record the black-tailed deer typically only by certain elements, because not all elements are distinguishable between the white-tailed deer or the black-tailed deer. But this bone in the hind leg, the metatarsal bone, is very diagnostic with respect to distinguishing between white-tailed and black-tailed deer. Black-tailed deer, also known as the mule deer. Their metatarsals are much longer than white-tailed deer metatarsals that you see on the left and at center. The left and center are modern white-tailed deer metatarsals. And that specimen on the right is a mule deer or black-tailed deer metatarsal. That's from the Mississippi River. We don't find any black-tailed deer in northeast Mississippi. They have not turned up yet. And I don't think they were here, frankly.
Texas mostly.
Yeah, probably so. They do find them in the Ice Age fossil record in Texas. Now, one way you can distinguish the deer is you find the antlers. You can distinguish the two deer by the way they bifurcate in the antlers. So, with respect to mule deer antlers, starting at the base, they bifurcate evenly, so that one branch is just about the same size as the other branch. Whereas in white-tailed deer, you always have the primary trunk and get branches from the primary trunk. We have elk remains preserved. as we do caribou, but the caribou is very rare. In fact, only 2 definitive caribou fossils, to my knowledge, have ever been found in Mississippi, and one of them is a small partial antler, and the other one is a large partial antler. Now, the latter lies in a private collection in, I think it's in Sulligent, Alabama. You may know who I'm talking about. And it is an impressive antler. But we have a copy of the other antler that was donated to the Smithsonian, and it's from a small individual. But those are the only definitive caribou remains we've found thus far. I don't have a real comprehensive collection. It's possible that I'm confusing some of my white-tailed deer with large white-tailed deer remains with caribou remains, because it's very hard, often with respect to the other parts of the skeleton, to distinguish the two. One that we have beyond a doubt, and based upon several specimens from the Mississippi River and the Lurse Bluffs, are stag moose. Stag moose was known to be common in the Mississippi River Valley, and it was unknown outside of the Mississippi River Valley and any other parts of Mississippi until a mutual friend of ours, Michael Harlow, found this molar, and I shared it on Facebook one time. And that is today a unique, nevertheless, proof that we had stag moose in northeast Mississippi. I was about to present at a meeting about a scientific meeting about our Ice Age fossils. And when Michael found this, I was about to say, there's no stag moose in northeast Mississippi, and he found that. So I had to include that in there. We also had Harlan's muskox in Mississippi. It was actually a small animal, as you can tell with the human for comparison. Buatherium bombifron. It's a scientific name that's just fun to say. And we had a variety of cats, a diversity of cats that is totally unexpected, I would think.
Did we have the elk before you leave the deer?
Yeah, we did. I just kind of glossed over it. I can't talk about them all.
That's good.
My goal was to at least name, or at least include on the slides, 100 species.
The only reason I mentioned that, we have found larger, thicker antlers, you know, and the Indians used the base up for that.
Right.
So,
So the ones I'm seeing, I think, are mostly subfossil. I don't think they go actually all the way back to the Pleistocene. But I'm still looking at samples.
Yeah,
I can't say that conclusively, but that's my suspicion based on what I've seen so far.
gotcha. Go back to your cat.
So, so we had a variety of cats, an even greater variety than what you see right here. Of course, these are all domestic cats, and as you guessed, these are my cats. When I made this slide, we had just lost one of our cats. By lost, I don't mean he ran off. I mean, he passed away.
Need some?
Yeah, I don't need to take any more cats. I don't even want a Pleistocene diversity of cats, because it was kind of diverse. Surprisingly, I still think it's surprisingly diverse. Well, we're going to introduce you to them. But I wanted to show you the current 3 that we have, because 2 of them are relevant to paleontology in the sense that they were found at fossil sites.
Okay.
Jill knows about KT. Here are the small cats that we had, or have recorded in our Pleistocene fossil record. We have this thing called a river cat. We had ocelot, and of course the bobcat still inhabits the area today. So the bobcat is extant, E-X-T-A-N-T, which means they're still living in the area today, or still living today. But the river cat is completely extinct, and the ocelot was apparently extirpated, possibly in early historic times, because the ocelot has been reported from Louisiana, at least in the older Louisiana records. They are recorded as being present in at least western Louisiana. But we consider them extraliminal today because they're not found in the area today. Here's some examples of river cat fossils. Now, at the time, the only river cat fossils we had were the femur and the jawbone. And I hate when this happens. It does happen. But when these fossils were sent to Helsinki, Finland to be examined by one of the world's foremost authorities on Ice Age carnivores, something happened to the package.
and the package was almost completely destroyed. Otherwise, these bones were relatively complete. The femur was complete, and the jaw was not broken up like that. In fact, most of that second tooth is missing. Much of it is missing. But it happens sometimes, but it was a real tragedy. We have ocelot remains based upon at least this bone, part of a jawbone right here. Now with the bobcat bone, for comparison, you'll see two little holes in front of the third premolar. The third premolar, they don't have a first and second premolar, cats do not. So the first tooth, also known as the third premolar, has two little holes out in front of it, okay? This is a hallmark of ocelot and bobcat osteology, or the science of the bones, the study of the bones. Those two foramina in bobcats are always in front of that third premolar, or the first tooth in the back of the jaw. In ocelots, they're always located beneath, immediately beneath the third premolar. So throughout this slideshow, I've kind of focused on some of the key or hallmark features that we're using to distinguish, because some of them are very relatable, and they're easy enough for you to see. A great many of them are not relatable in fewer than 8 words. For example, a classic example of that is, how do you define a dinosaur? There is no easy way to define a dinosaur. There is a way to define a dinosaur. But to sum up those 8 characters, half of those are meaningless to your average person because they involve obscure parts of the skull and the ankles. Here's an example of an ocelot skull, a modern ocelot skull. And where are those 2 holes? Right beneath that third premolar. We have cougar recorded. In fact, we just received the donation of our 6th or 7th cougar fossil. Came from a member of the Mississippi Gem and Mineral Society just this past week. And it was a metatarsal bone, a bone from the foot. Yeah, so all of the 6 bones that we have, they're from different parts of the body. But it's always good to get elements from the different parts of the body to reassure you that you're dealing with cougar. An example of that has to do with the ground sloth remains. So for years, we only thought we had one ground sloth. We had all of these bones of giant ground sloth, but apparently we had nothing diagnostic of a second sloth called Harlan's ground sloth. There are only certain bones in Harlan's skeleton that are truly diagnostic of that animal. And we didn't have those bones. At least they were obvious, their diagnostic potential was not obvious to me or people that I was sharing them with. But eventually, we could see that 40% of our ground sloth bones were actually from a second species. And a lot of that had to do with my education as well. But it's hard to see some of these features sometimes, so you need more bones to be able to tell.
Sloth's not in Mississippi, you think?
No, we do have giant ground sloth.
No.
But we know we have 2 now.
Okay.
And so we used to think it was just 1, but now we're
Oh, okay, gotcha.
confirmed that we had 2. So there are also jaguar present, American lion, and the saber-toothed cat. Here's an example of one of our jaguar fossils, and it's not a common fossil. This is a toe bone found by one of our former employees. And here is our most recent acquisition of an American lion fossil, which is the radius bone, this bone in your arm, from the Mississippi River, around Rosedale, Mississippi. Compared to a black bear and a jaguar. So a massive beast. And the very first lion fossil ever found was found in Natchez, Mississippi. It was presumably found in St. Catherine's Creek Wildlife Refuge area, and that's based upon its preservation. I never saw the actual fossil, but we do have a cast of it, and I've seen detailed pictures of the original. This is a picture of the cast that we have in the collection. And based upon their based upon the pictures that I have, their preservation of this jawbone is identical to what we see in the fossils that are coming out of St. Catherine's Creek in Natchez. So we believe it was found there. It was found prior to the 1830s. And something found that far back, apparently it was in private hands for at least a couple of decades before it made its way on its long journey on a train to the Philadelphia Academy of Natural Sciences. Now, there's another cast of this specimen, not just the one that we have, and there are probably multiple casts, but there's a bronze cast of this specimen cradled in the arm of this bronze statue of one of the founders of American vertebrate paleontology, Dr. Joseph Leidy. And of all the things that he could have been posing with in his permanence, rendered in bronze, and he achieved a lot of things in his career. He found lots of fossils, most of the fossils he described were from the western US, from what was at that time considered the frontier. But of all those places, and all those things that he found, he chose to be rendered, or maybe the people that rendered him in this bronze, chose to pose him with this American lion fossil, cradled in his left arm. So obviously it was very special to him and to the Academy. And the knowledge of lions in North America did not exist outside of one false report that happened, that was generated by an American president who falsely thought that he was finding some kind of lion fossils on his property.
Roosevelt.
It was Roosevelt.
Jefferson?
It was Thomas Jefferson.
Yeah.
Thomas Jefferson, he was that guy that loved to go out rock hounding,
Yeah.
and he'd probably do it in his formal dress. He conducted excavations. We've got pictures of him involved in excavations, information, records of him searching for fossils, identifying people's fossils. And he thought, based upon the first ground sloth remains, that largely on the claws, he surmised that those giant ground sloth claws, because they get big, that we must have had a giant lion living in North America. And that persisted for a few years, but later it was understood that that belonged to a giant ground sloth.
That claw that you got from that boy a few years ago from Pine Top?
Yeah.
Was that a
Mi-
claw?
Yeah, Michael Estes,
Yeah.
yeah.
Is that what that was?
It sure was.
Nice one.
Yeah, it was. It was missing the outer sheath.
Yeah.
They had this bony sheath that protected their nail bed, but it often breaks away, easily breaks away. So yeah, the very first lion fossils in Mississippi are very rare. Several jaws have come to light over the years, and a recent one has made social media news. We were talking about that one earlier today. But they are very rare. They are very abundant in the tar pits in northwestern Mexico and in California, like La Brea tar pits. They are relatively abundant, certainly much more so than they are here in the east. And they are found in Florida as well. Carnivore remains in general are very rare. The very first saber-toothed cat fossil that ever came to light, I was probably 17 or 18 years old when a friend of mine, a rock hounding buddy of mine, found that tooth on the left in this picture compared to a tooth from the La Brea tar pits, which I later identified with the help of someone from the University of Florida as a milk tooth of a saber-toothed cat. So it's not even an adult tooth, it's from a milk tooth. But it was the first saber-toothed cat bone donated to the museum. And I was still sort of volunteering at the time when I was telling people about this donation of a saber-toothed cat fossil to the museum. And I remember showing people when Dr. Daly, when she was a curator there before I worked there, she would allow me to go into the collection and show people things. And I would tell them about the saber-toothed cat fossil, sort of intentionally trying to get their hopes up that they would see like a saber. And that's what people expect. But something has a name that is descriptive of a prominent feature about them, that's, well, that must be what the museum has. Well, no, to this day, we do not have a saber from a saber-toothed cat. Part of one was found, and it's still in a private collection. The base of a saber-toothed cat, the root of a saber-toothed cat saber was found. The crown had broken off.
That's mainly Mississippi you're concerned with that, right?
Pardon?
That's mainly Mississippi you're talking about, right? That we don't have.
Oh, right. I'm talking, exactly. When I say we, I guess I'm
Do
referring
they
always.
have others in other states?
Oh, yeah, absolutely, yeah. But you are correct to make that point, that When I say we, I'm talking about Mississippi. Pardon me if that's never clear.
No, I just wanted.
No, that's a good point. That's a relevant point.
I
Saber-toothed cat bones, like American lion bones, are relatively common in the La Brea tar pits. And a few other places as well. Sometimes pictures of the bones, in fact, regularly, pictures of the bones do not do a bone justice with respect to its major characters when you're trying to share information about that bone with other specialists. Sometimes it becomes necessary to draw a bone to share information about that bone because regular light photography does not capture, because of the way the surface of a bone is reflective. Now, there are coatings that you can put on fossils to decrease that reflection. There's a variety of them, but you have to put them on very thin, and that's often challenging to do. You can't make them too thick. One way to get around that is by drawing or illustrating, and that's what they used to do in the distant past. As the earliest descriptions of fossils were drawings. But it's important that the artist not be too subjective, always be objective when they're reproducing the bone. And that was not always the case with the earliest drawings. Some people took artistic license. They would draw something the way that maybe they thought God would have wanted it to be, or maybe they wanted to make it more symmetrical. And that happens with sea urchins. I do a lot of work with sea urchins. And a lot of the early illustrators want to make it more round, but it wasn't always that round. But anyway, all that aside, illustrations can often convey important information that pictures cannot. And when I was at North Carolina State University, I had one such bone in my thesis collection that just kept reflecting too much light. And there was an undergraduate student at the time. I was working on my MS, and her name was Holly Woodward Ballard. She was Holly Woodward at the time. And this is her first drawing she ever made of a fossil. She was mostly doing biological drawings. This is her first drawing of a fossil. And I have it at the museum, and now she's this world-famous paleontologist today. She's a dinosaur paleontologist. And I've seen her on Facebook, and I've often thought about reaching out to her and asking her if she wants a copy of that, her first drawing, because she did not keep a copy of it for herself. So, a lot of cats, this incredible cat diversity during the Ice Age. It kind of staggers the mind. We don't find a lot of them, but it's nevertheless a diverse assemblage of cats. We also have smaller carnivores, like this mink jaw. It's our only mink fossil, or it's our best mink fossil. We have 2 mink fossils. Sadly, though, this is one of those cases. It happens. We had turned this bone over to someone that was creating a display for us, fabricating a display. And that was back before I was there. And it was right after my predecessor had left, and there was no paleontologist there to supervise the handling of the specimens. And it broke. And so that's 100% of the specimen right there. But it's only, 70% of the jaw, maybe even 60 to 65% of the jaw. Now there's only 40% of the jaw. But they just almost ruined its diagnostic potential. They were just so hard on it. But it happens. I will say that those people were generally incompetent based upon their construction of that exhibit. And it happens, doesn't it, Jim? And those people went out of business about 3 years later. We have a variety of canid remains, like the red fox. In this series of pictures, I'm comparing a red fox jaw on the left, the teeth of a red fox upper jaw, to a fossil found near Mayhew, again, a very productive fossil site, and then a gray fox tooth, the same position. These are the M2s. And you can see how the topography of the crown is different from one to the other. And this is just an example of the types of comparisons that we make. Here's an example of a gray fox jaw with no teeth. Teeth are often very species diagnostic. In this case, we had no teeth, but the bone in this case, just the jaw itself, was sufficiently diagnostic to distinguish it from red fox. We have coyote remains, or something that resembles coyote. It's still indefinite how to define exactly what it is, but it's at least coyote adjacent. And of course, we have several dire wolf remains. It seems to have been one of the commoner carnivores based upon the number of remains we have. And just look at the size of this fragmentary jaw found by Jacob Tucker of northeast Mississippi. He's a prodigious collector.
How do you distinguish that from others?
Well, I won't belabor that part, but I will point out
Like
how,
this, see?
yeah. So they're very similar in general shape, but there are some subtleties that you and I can talk about that later.
Okay.
But I've already betrayed these people's trust in hoping this talk will be at least under an hour and a half. But this jaw, for comparison, is from a Great Pyrenees, one of the largest breeds of dog in the world. I didn't have a wolf jaw. We don't have a wolf jaw. But compared next to dire wolf jaw. And just look at that size difference, particularly in the carnassial tooth, that's this tooth right here, compared to that to the Great Pyrenees. So, quite a diversity of canids, but the only extinct one for certain is the dire wolf. And this coyote-like thing, it's almost a cross between a red wolf and a coyote, at least with respect to bones. But nevertheless, it's still sort of ethereal. It's hard to define what that is. And of course, we had 3 bears. Not these bears, but these bears. The black bear, the Florida spectacled bear, and the great short-faced bear. We had no cave bears. There are no cave bears in Mississippi. That was strictly a Eurasian phenomenon, a Eurasian animal. But we did have at least 2 pretty impressive big bears, one in particular, the great short-faced bear, the largest of the Ice Age bears. The black bear remains in our Ice Age fossil record are the most common. The second most frequently encountered bear fossil would be that of the spectacled bear, which is a type of bear that is related to the short-faced bear. They fall in this subfamily of bears called the Tremarctines. The Tremarctines are how we get this term Tremarctos, which is the genus name of the Andean bear, also known as the South American spectacled bear. Now, our Florida spectacled bear, we don't know whether it had spectacles or not, okay? So the common names are useless in this regard. We only call it the Florida spectacled bear because its closest living relative has spectacle. Again, we're not inferring that this thing was actually spectacled or not. But it was a convenient name to give it in demonstrating its relationship to the modern spectacled bear, which obviously, as you can see from this relaxed fellow here, is spectacled with the black spots and the light-colored eyelids. This jaw on the left is a spectacled bear found on the Mississippi River. And his jaw on the right is a modern black bear jaw. And one of the hallmark features, there are several features to distinguish these bones and the teeth that they bear, so to speak, no pun intended. But one of the major features of the bone is this ridge that runs right through the middle of this muscle attachment site. This is a depression in the back of the jaw, this circular sort of bowl shaped right here. But there's a ridge that divides that depression. The depression is called a fossa, and those are usually muscle attachment sites, and these fossae. And this fossa right here was an attachment site for the masseteric jaw muscle, which is used primarily in opening the jaw, but also in chewing, involved in a number of things. But that muscle was split into 2 parts, represented by the ridge that divides that depression in the spectacled bear. The great short-faced bear also had this division in that jaw, as you can see in this specimen on the right there. Our second short-faced bear fossil was found by this young lady, pictured on the far left, Sarah Thomas. I met her at her father's auction. Her uncle, her estranged uncle, as it were, great uncle, was a collector. He was a rock hound. He accumulated a lot of things, He lived in Rosedale, Mississippi, and owned a reconstruction home there, a home that dates to the Reconstruction. And that's what they were auctioning off, was the contents of the home, and the home itself was the last thing sold. But this guy also wanted to auction off some of the fossil bones, which he did, but I convinced him to donate a bunch of things before the auction. And when Sarah, the young girl, and she already showed me this big bone that she's holding, and it's the femur of a great short-faced bear. And she saw how grateful I was with respect to her father donating that material, and I really built up the donation and how important it was. She decided to donate her big bone. I was not, totally caught me off guard, because I wasn't very proud of it, but she donated that to the museum as well. So I've talked about the lions and the tigers and the bears. So I have fulfilled my Wizard of Oz obligations. Now let's talk about these animals that are called the edentates, and then we will be done. The edentates, the armadillos and the giant ground sloths, are called such not because they necessarily have or lack teeth. Some of them do. But in this case, they lack enamel on their teeth. And for that reason, their teeth don't preserve very